Tonight, we are going to explore a simple idea. What if the world around you isn't made of atoms, but of light and logic? Just for tonight, let's imagine that everything you see is part of a perfect, peaceful simulation. Let me ask you something before we begin. What if everything you have ever experienced, every sensation, every thought, every moment of joy and grief and boredom and wonder, what if all of it is data? Not a metaphor, not a poetic comparison. Literal data, strings of numbers, ones and zeros, or whatever the computational equivalent turns out to be, running on hardware somewhere, processed by something that from the outside looks nothing like a universe and everything like a machine. What if you are not a person living in a universe? What if you are a program running in a simulation? And what if the simulation was built deliberately, intentionally, with a specific purpose by a civilization so far in the future that the distance between them and us is greater than the distance between us and the first single-celled life that ever existed on this planet? This is not a science fiction premise. This is a serious philosophical argument made by serious people, published in serious academic journals, taken seriously by some of the most rigorous thinkers alive. And tonight, as you lie in the dark and let your body rest and let your mind wander wherever it needs to go, we are going to follow this argument all the way to the end, through the philosophy and the physics and the mathematics, through the history of where this idea came from, through what it would mean if it were true, what it would mean if it were false, and what it suggests about the nature of reality, of consciousness, of what it means to be alive at all. Take a slow breath. Whatever is true about the nature of your existence tonight, whether you are a biological organism in a physical universe or a pattern of information in a vast computation, you are here. Something is experiencing something. Some kind of awareness is noticing this voice, this darkness, this moment. That much is real. Whatever else is uncertain, that is not. Let us begin. The modern version of simulation theory, the version that has captured the imagination of physicists and philosophers and billionaires and ordinary people lying awake at night, was presented in its clearest form by a philosopher named Nick Bostrom in 2003. Bostrom is a Swedish-born philosopher at Oxford University. He is not a science fiction writer. He is not a mystic. He is an analytic philosopher of the most rigorous kind, the kind that builds arguments in precise logical steps and checks each step carefully before proceeding to the next. In 2003, he published a paper called "Are You Living in a Computer Simulation?" The paper was not long. It was not dramatic. It was written in the dry, careful language of academic philosophy, and it argued something that most people, when they first encountered it, found either immediately obvious or immediately absurd. Very few found it somewhere in between. The argument goes like this. One of three things must be true. Either almost all civilizations at our level of technological development go extinct before they ever reach the stage of being able to run detailed simulations of conscious beings, or almost all civilizations that do reach that stage simply choose not to run such simulations, for whatever reason. Ethical concerns, lack of interest, some cultural or technological development that makes simulations unnecessary or undesirable, or we are almost certainly living in a simulation right now. Bostrom called these the three possibilities, and he argued that exactly one of them must be true, that they exhaust the logical space, that there is no fourth option. The logic is simple, but airtight enough that it has resisted serious refutation for over 20 years. Let us walk through it slowly. Start with a question. Is it possible, even in principle, to simulate a conscious mind on a computer? This question touches on some of the deepest problems in philosophy: the nature of consciousness, the mind-body problem, the question of what gives rise to subjective experience. We will return to all of those tonight. But for the purposes of Bostrom's argument, let us accept what seems to be at least plausible, that the brain is, in some fundamental sense, an information processing system. That thought and experience and consciousness arise from the physical processes that occur in the brain as it processes information. If that is right, if consciousness is substrate independent, if what matters is the pattern of information processing rather than the specific physical stuff doing the processing, then it is at least possible, in principle, that a sufficiently powerful computer could run a program that produces consciousness, that processes information in a way that gives rise to experience. Not a simple program. Not anything we could build today, or in the next 100 years, or possibly in the next 1,000 years. But eventually, at some point in the future, given enough computing power, enough time, enough understanding of how the brain works, if a civilization survives long enough and advances far enough, it will acquire the ability to simulate minds. Now let us think about what such a civilization would do with that ability. Imagine a civilization 1,000,000 years more advanced than ours. We have existed as a technological species for perhaps 10,000 years. We have had computers for less than 100. We have had powerful computers for less than 50. A civilization 1,000,000 years ahead of us would be to us what we are to the bacteria that first evolved on this planet. The gulf is almost beyond imagining. Such a civilization might have computing resources that dwarf anything we can currently conceive. The physicist Frank Tipler has estimated that the computational resources available in the far future, as stars burn and as various physical processes play out over cosmological timescales, would be essentially unlimited. Even without such extreme estimates, it seems safe to say that a sufficiently advanced civilization would have access to computing power far beyond what we currently possess. Power sufficient to run not just one simulation of a mind, but many, many thousands, many millions. And what might such a civilization want to simulate? Its own history, perhaps? Out of curiosity, out of scholarship, out of something like nostalgia, the way we watch documentaries about the past, out of scientific interest in understanding how they came to be, what their ancestors were like, how history might have unfolded differently. If a civilization wanted to understand its own past, and why would it not? It would run simulations of earlier stages of its development, simulations of what it was like when it was primitive, simulations of beings like us. And each simulation might contain many minds, billions of them, all living their simulated lives, completely unaware of the computational substrate on which their existence depends. Now here is where the mathematics becomes arresting. If even a small fraction of advanced civilizations choose to run such simulations, the number of simulated minds in the universe would vastly, overwhelmingly outnumber the number of biological minds. Think about it this way. Suppose there is one real civilization, biological, evolved, living in the base level of physical reality. And suppose that civilization reaches the point where it can run ancestor simulations. And suppose it runs just a few of them, 100, 1,000. Each simulation contains billions of minds. So now there are billions of simulated minds for every biological mind. If you were randomly selected from among all the minds that exist biological and simulated, what is the probability that you are biological? Vanishingly small. Almost certain you are simulated. Not because simulated minds are somehow inferior or less likely to be conscious, but simply because there are so many more of them. The logic is statistical. It does not require any metaphysical claim about the relative value of simulated versus biological existence. It just requires counting. And when you count, when you take seriously the possibility that a civilization far more advanced than ours could run many simulations, each containing many minds, the numbers overwhelm any reasonable prior probability that you are among the tiny minority of biological beings. This is the core of Bostrom's argument. If simulations are possible, and if advanced civilizations run them, then almost certainly you are in one. There is one further complication that makes the argument even stranger. Simulations can contain simulations. If we are in a simulation, and if the beings in our simulation advance far enough, they too might eventually build simulations. Simulations within the simulation, each one containing its own simulated minds, who might in turn build their own simulations. An infinite regress of nested simulations, each containing the next. If this is possible, and there seems to be no logical reason, it is not then the number of simulated minds in all the nested levels combined would be even more astronomically larger than the number of biological minds. The probability of being at the base level of reality, of being among the truly biological, non-simulated beings, would be not just small, but infinitesimally small. The philosopher Nick Bostrom and others have explored what this nested structure would mean for the simulation argument. One conclusion is striking. If nested simulations are possible, then almost certainly we are not just in a simulation, but in a simulation deep within a stack of simulations. Layers upon layers of computational reality, each one running inside the next. We have no way of knowing how deep the stack goes. We have no way of knowing whether there is a bottom, a true base reality, or whether the nesting continues without end. This is one of the genuinely vertiginous implications of taking simulation theory seriously. Not one layer between us and base reality, but possibly many. Possibly uncountably many. A hall of mirrors, each mirror reflecting another mirror, without any of them being the wall behind. The only escape routes are the other two possibilities. Maybe civilizations like ours almost always go extinct before reaching the point of being able to run such simulations. The great filter, some catastrophe, nuclear war, climate collapse, pandemic, asteroid impact, or something we have not yet imagined that ends technological civilizations before they can become advanced enough to simulate their ancestors. If that is right, then the reason we do not find ourselves in a simulation is simply that simulations are very rare because the civilizations that would run them almost never survive long enough to do so. This is a deeply unsettling possibility in a different way, because it means that the silence of the universe, the fact that we have found no evidence of other intelligent civilizations, despite decades of searching, is not just a puzzle, it is a warning. Evidence that something terrible awaits civilizations at roughly our stage of development. Evidence that we are probably next. So that escape route from the simulation hypothesis leads somewhere dark. The other escape route is that advanced civilizations simply choose not to run ancestor simulations. Maybe for ethical reasons. Maybe because simulating conscious beings who do not know they are simulated is considered a form of deception or harm. Maybe because the beings in the simulation would suffer, and causing unnecessary suffering, even virtual suffering, is considered unacceptable. Or maybe because something about the process of advancing to the point of being able to run simulations changes civilizations in some way that makes running them unattractive. Maybe the wisdom that comes with technological maturity includes the wisdom not to play God. This is possible, but it would require essentially all advanced civilizations to make the same choice. For the argument to work for this to be the correct escape route, the decision not to simulate must be nearly universal among advanced beings, which seems like a strong claim about the uniformity of values across the vast diversity of possible civilizations. So we are left with three possibilities. Extinction is the normal fate of civilizations like ours, or advanced civilizations universally choose not to simulate, or we are in a simulation. And Bostrom's argument does not tell us which of the three is true. It just tells us that one of them must be, which means that if you think we are likely to survive and reach technological maturity, and if you think that some advanced civilizations would probably choose to run simulations, which seems reasonable given the extraordinary diversity of motivations a million civilizations might have, then you are pushed by sheer logic toward the third possibility. We are in a simulation, and the universe we think we inhabit, the stars, the galaxies, the billions of years of cosmic history, is a story being run on a machine. It is worth pausing here to notice the elegance of this argument. It does not require any exotic assumptions. It does not require that consciousness be something mysterious or non-physical. It does not require any particular view about the nature of the universe. it requires only three things. 1. That consciousness can, in principle, be computationally simulated. This seems at least plausible, given that the brain is a physical system, and physical systems can be, in principle, modeled computationally. 2. That advanced civilizations would have the computing power to run such simulations. This seems nearly certain, given the trajectory of technology and the timescales available. 3. That at least some advanced civilizations would choose to run ancestor simulations. This seems reasonable, given the extraordinary diversity of motivations that a large number of different civilizations would have. Grant all three, and the statistical argument is overwhelming. And the only way to avoid the conclusion is to deny one of the three premises, to argue either that consciousness cannot be simulated, or that civilizations almost never survive to the relevant level of advancement, or that advanced civilizations almost universally decline to run simulations. Each of these is possible, none is obviously right, which is why the argument is taken seriously by serious people, which is why it is worth spending a night with. Let that land for a moment. Not as a frightening thought, not as something that threatens the reality of your experience, as a philosophical possibility, a logical consequence of a few simple premises about the future of technology. You are lying in the dark. Something is aware of this moment. Whatever the substrate of that awareness, neurons firing in a biological brain, or information processing in a computational simulation, the awareness is real. The experience is real, and the question of whether the physical stuff underlying that experience is made of atoms and quantum fields, or of bits processed by a machine, somewhere, that question is genuinely, seriously, rigorously open. Breathe with that. The night is long. We have only just begun. The idea that the world is not what it appears to be, that there is a layer of reality beneath the surface of ordinary experience, more fundamental, more real, is not new. It is in some form one of the oldest ideas in human thought. Long before computers existed, long before philosophy developed the technical vocabulary to discuss it precisely, long before physics gave us the tools to ask about the fundamental nature of matter, the intuition that what we perceive is a construction, a representation, a shadow of something deeper. This intuition appears in cultures separated by thousands of miles and thousands of years. And the simulation. Hypothesis, in its modern form, is in many ways the latest expression of this ancient intuition, dressed in the language of computer science, made rigorous by mathematical argument, but recognizably part of a conversation that has been going on since human beings first had the capacity for abstract thought. In ancient India, perhaps 3,000 years ago, Hindu philosophy developed the concept of Maya. We encountered this idea briefly when we explored solipsism, but it is worth returning to now because in the context of simulation theory, it takes on a different dimension. Maya is usually translated as illusion, but that translation loses something important. The Vedic teachers did not mean that the world is fake in the way that a stage set is fake, a deliberate deception with nothing real behind it. They meant something more subtle. They meant that the world as we experience it, the multiplicity of separate things, the appearance of solid matter, the sense of being a separate self in a world of other separate things, is a particular form of appearance. A particular way that something deeper takes shape in experience. The deeper thing, Brahman, the fundamental ground of reality, is not a multiplicity of separate things. It is one, undivided, without boundaries. And what we experience as the world is Brahman appearing to itself in a form that involves apparent separation and multiplicity. The world is real, but the form it takes, the appearance of solid matter, separate objects, separate selves, is a kind of overlay on a deeper reality. Now run this image through a modern lens. What is a computer simulation? It is a process, a computation that produces, in the experience of those within it, the appearance of a physical world with solid objects, separate things, causal relationships, the passage of time. The underlying reality is mathematical, equations, information, process. The experienced reality is a world that looks and feels and behaves like a physical universe. The simulation is Maya in silicon. The deep reality is the computation. The experienced reality is the world the computation generates. And the beings within it, the simulated minds, experience the world, not the computation. They see the Maya, not the Brahman. 25 centuries ago in ancient Greece, Plato described something he called the allegory of the cave. Prisoners are chained in a cave, facing a wall. Behind them, there is a fire. Between the fire and the prisoners, other people pass, carrying objects. The shadows of those objects are cast on the wall the prisoners face. The prisoners cannot turn around. They cannot see the fire, the people, the objects. They see only the shadows. And so they believe the shadows are reality. They learn to name the shadows, to predict their movements, to understand their world in terms of those shadows. The shadows are, for them, all there is. Then one prisoner escapes. He turns around. He sees the fire, the people, the objects. He realizes that what he thought was reality was only a shadow, a two-dimensional projection of something three-dimensional and real. He climbs out of the cave. He sees the sun. He sees the world lit by sunlight rather than by firelight. He returns to tell the others. They do not believe him. The shadows are, for them, still all there is. Plato's allegory was about the difference between ordinary perception, the world of appearances, and philosophical knowledge, the world as it really is. He used it to make a point about education and enlightenment and the life of the philosopher. But the structure of the allegory is strikingly familiar. Beings who believe their world is real, when in fact it is a representation, a projection of something else. Something they cannot directly perceive, a constructed appearance whose underlying reality is entirely different from how it seems. Run this through the simulation hypothesis. The prisoners are simulated minds. The shadows are the simulated world. The fire, the mechanism producing the shadows, is the computer running the simulation. The sun, the true light, the true reality, is whatever exists outside the simulation, the base-level reality in which the computer runs. Plato did not mean to describe a computer simulation. He had no concept of computers. He was making a philosophical point about perception and knowledge and the relationship between appearance and reality. But he stumbled with extraordinary precision onto the same structure that the simulation hypothesis describes. The world as it appears is not the world as it is. What you see is a projection. The real thing is elsewhere, underlying, hidden. There is another strand of ancient thought that runs even closer to simulation theory, and that comes from an unexpected direction. Zhuangzi, the Chinese philosopher we encountered when exploring solipsism, had a number of arguments and parables that bear on the simulation question. He wrote about what he called the transformation of things, the idea that what we take to be fixed, solid, and certain is in fact fluid, contingent, and continuously becoming something else. In one story, a cook butchers an ox with such perfect skill that his knife never touches bone. He simply finds the natural spaces in the structure of the animal and moves through them. Zhuangzi used this as a metaphor for how to move through a world whose structure you understand deeply. But behind the metaphor is a claim about reality itself. Reality has a structure, a deep structure that is not immediately apparent on the surface. The experienced world, the solid, ordinary world of objects and events, is like the flesh of the ox. The deep structure, the Tao, the underlying order, is like the spaces between. You can move through it if you know how, but you cannot see it just by looking at the surface. The simulation hypothesis says something similar. The experienced world is the rendered surface. The deep structure is the computation. The Tao and the algorithm are playing analogous roles in analogous pictures of the relationship between appearance and reality. In the Western tradition, the idea that the world might be more like a dream or a mental construction than a solid, independent reality runs through Leibniz, through Berkeley, through Schopenhauer, through Bergson, through a long tradition of idealist philosophy that never quite accepted the straightforwardly material picture of the world that Newtonian physics seemed to offer. Schopenhauer, writing in the 19th century, built his entire philosophy around a distinction between the world as representation, the world as it appears to us, organized by our perceptions and our minds into a coherent picture, and the world as will the underlying reality, a blind, striving force that has nothing directly to do with the organized appearance we experience. His language was not computational, but his structure was familiar. The world you experience is not the world as it is. It is the world as it is represented to you by your mind and senses, organized, filtered, made coherent, turned into a picture that your consciousness can navigate. The underlying reality is something else entirely. The simulation hypothesis is, in many ways, the most technically precise version of this ancient and recurring insight. The world you experience is not the world as it is. It is the world as rendered by the simulation. The underlying reality is computational, and the relationship between the two is not deception, it is just the nature of how mediated experience works. In 17th century France, René Descartes, whose radical doubt we have already visited in our exploration of solipsism, imagined what he called an evil demon, a supremely powerful, supremely deceptive being who arranged reality so that everything Descartes experienced was false. The physical world, other people, mathematics, logic, all of it could be the demon's illusion, fed to Descartes' mind to deceive him. Descartes used this as a thought experiment to find the bedrock of certainty, the one thing that could not be doubted. He found it. Cogito, ergo sum. I think, therefore I am. Even if the demon is deceiving him, there must be a him to deceive. But notice what the evil demon is. It is an entity with computational power, the ability to feed a mind a completely convincing false reality. It is a simulation engine. Descartes' evil demon and Bostrom's simulator are structurally the same thing. An entity outside the experienced reality, constructing and maintaining a false world that the experiencer cannot distinguish from a true one. The demon is the programmer. The victim of the deception is the simulated mind. Descartes was running the simulation thought experiment in 1641, 3.5 centuries before the word simulation took on its modern computational meaning. And then, in the 20th century, something changed. Not in the philosophy, not in the ancient intuition, but in the technology, in the concrete reality of what human beings were building. Computers. The first programmable electronic computers appeared in the 1940s. Enormous machines, filling rooms, consuming enormous amounts of power, capable of performing calculations that would take human mathematicians years. Within decades, the computers had shrunk to desktops, then to laptops, then to phones that fit in a pocket and contain more computing power than all the computers in the world combined at the time of Descartes. And as computing power grew, the simulations grew. First, simple mathematical simulations models of physical systems, of weather, of economic behavior. Then, visual simulations, graphics, video games, worlds you could navigate on a screen. Then, three-dimensional immersive environments, virtual reality, spaces you could enter and move through that had their own rules of physics, their own aesthetics, their own inhabitants. And as these simulated worlds grew more sophisticated, something happened that was both obvious and unsettling. The people who built them started asking, how do we know we are not in one? There is a specific observation about the trajectory of technology that makes this question feel more urgent than it might otherwise. Moore's law. The observation that computing power roughly doubles every 2 years held for decades. It has slowed recently, but the underlying principle that technological capability grows exponentially shows no signs of stopping. Consider what has happened in a single human lifetime. In 1950, the most powerful computers in the world filled entire rooms and could perform thousands of calculations per second. They were used by governments and universities. Almost no one ever interacted with one. In 1980, a personal computer sat on a desk and performed millions of calculations per second. Millions of people owned one. In 2000, a laptop performed billions of calculations per second. Billions of people carried one. In 2024, a smartphone in a pocket performs trillions of calculations per second and fits in a palm. In 2050, if current trends hold even partially, the computing power available to an ordinary person might be incomprehensible by today's standards. Now project this forward, not by decades, but by centuries, by millennia, by millions of years. The physicist Seth Lloyd calculated that a computer the size of a human brain, using every atom in the brain for computation, could perform approximately 10 to the power of 43 operations per second. That is a number so large it has essentially no analogy in ordinary experience. A civilization 1,000,000 years more advanced than ours might have access to computing power that dwarfs even this estimate. Power drawn from stellar energy, from the conversion of matter itself into computational substrate. With that kind of power, running a detailed simulation of an entire civilization, billions of minds, each processing at the rate of a human brain, embedded in a consistent physical world with coherent physics would be, from their perspective, perhaps no more demanding than running a weather model is from ours. Which means the question is not whether such simulations are conceivable. They clearly are. The question is only, do they run them? The game designer and philosopher Nick Land wrote about this. The physicist Max Tegmark built an entire theory of the mathematical universe that has direct implications for simulation. The entrepreneur Elon Musk said publicly, more than once, that he believes the probability that we are not in a simulation is 1 in billions. The physicist Neil deGrasse Tyson said that if he had to bet, he would bet we are in a simulation. These are not lunatics. These are not people on the fringes of thought. They are among the most intellectually accomplished people of our time. And they think it is at least as likely as not that they are living inside a computer program. Why? Because they understand computers. Because they have seen how fast the technology moves. Because they look at the trajectory of human computing power and can extrapolate where it leads. And where it leads, within a timescale that is very short on cosmological scales, is to simulations indistinguishable from reality. We can already make video games that look photorealistic. We can already create virtual environments that fool the senses. We can already build AI systems that behave in limited contexts, as if they have something like thought. In 100 years, or 1,000 years, or 10,000 years, if we survive, what will we be able to build? If the answer is simulations of entire universes, complete with simulated minds, and that answer seems at least plausible, then the question of whether we are already in one becomes very hard to dismiss. Let the breath deepen. Let the ideas settle into the quiet parts of the mind that do not need to evaluate or argue, just receive. We are somewhere in the space between the ancient cave and the modern data center, between Plato's shadows and Bostrom's argument, between the intuition that the world is not what it seems and the rigorous logic that suggests, statistically, it probably isn't. And all of this thinking and wondering and building and asking is happening inside something. Whether that something is a physical universe or a computational process, it is the context within which awareness exists tonight, which is, however you describe it, remarkable. Philosophy and logic are one thing, but physics is another. And what is striking about the simulation hypothesis is that it does not just find support in philosophical argument. It finds echoes, strange, unexpected, unsettling echoes in the actual physical structure of the universe. Not proof. Nothing in science is proved, only confirmed to various degrees. But hints. Coincidences that do not feel quite like coincidences. Features of reality that seem to rhyme with what you would expect if reality were computational. Let us walk through some of them. The first is perhaps the most striking. The universe appears to be fundamentally digital. Not in the metaphorical sense of being well described by mathematics, though it is, but in a more literal sense. At the smallest scales far below anything we have directly measured, but where our best physical theories point, the universe appears to be discrete rather than continuous. The Planck length, approximately 1.6 times 10 to the power of negative 35 meters, is the smallest length that has any physical meaning in current physics. Below this scale, space itself breaks down. The concept of distance becomes undefined. You cannot subdivide space infinitely at some point. You hit the pixel. This is not certain. Our physics is not complete at these scales. We do not have a fully consistent theory of quantum gravity that would tell us definitively what happens at the Planck scale. But the indications are there. Space and time appear to be granular at the smallest scales. Quantized. Not infinitely divisible, but made of discrete units, the smallest possible chunks of space and time. And discrete, quantized structure is exactly what you would expect in a simulation. A computer operates in discrete steps. It does not process continuously. It processes in clock cycles. It stores information in discrete bits. It does not model reality with infinite precision. It models it to whatever precision is sufficient, cutting off at some minimum scale below which it does not simulate. A universe running on a computer would have a minimum length scale, a pixel size, a resolution limit. Below that scale, there would be nothing. Not because space is infinitely small there and too small to matter, but because the simulation does not model anything that small. The Planck length looks to some physicists rather like a pixel size. The second clue is the speed of light. In a simulation, you would expect there to be a maximum speed of information transfer, a rate at which updates propagate through the simulated space, a speed limit beyond which nothing can move, because the computation cannot process information faster than a certain rate. In our universe, that maximum speed is the speed of light, approximately 300,000 kilometers per second, absolute, inviolable. Nothing, no matter, no information, no influence of any kind can travel faster. Where does this speed limit come from? Why is there a speed limit at all? In general relativity, the speed of light emerges naturally from the geometry of space-time. It is the speed at which massless particles travel through the four-dimensional structure we discussed in our exploration of the block universe. But why is space-time structured so that there is such a limit? Why not infinite propagation speed? Why is there a maximum at all? In a simulation, the answer is natural. There is a maximum propagation speed because the computer processes updates at a finite rate. Information cannot propagate faster than the computer can process it. The speed of light is not a feature of some physical substance. It is a feature of the clock speed of the simulation. This does not prove we are in a simulation, but it rhymes. The second clue is the speed of light. In a simulation, you would expect there to be a maximum speed of information transfer, a rate at which updates propagate through the simulated space, a speed limit beyond which nothing can move because the computation cannot process information faster than a certain rate. In our universe, that maximum speed is the speed of light, approximately 300,000 kilometers per second, absolute, inviolable, nothing no matter, no information, no influence of any kind can travel faster. Where does this speed limit come from? Why is there a speed limit at all? In general relativity, the speed of light emerges naturally from the geometry of space-time. It is the speed at which massless particles travel through the four-dimensional structure we discussed in our exploration of the block universe. But why is space-time structured so that there is such a limit? Why not infinite propagation speed? Why is there a maximum at all? In a simulation, the answer is natural. There is a maximum propagation speed because the computer processes updates at a finite rate. Information cannot propagate faster than the computer can process it. The speed of light is not a feature of some physical substance. It is a feature of the clock speed of the simulation. This does not prove we are in a simulation, but it rhymes. The third clue comes from the constants of nature. The universe runs according to physical laws, and those laws contain specific numbers constants that have to be exactly what they are, or the universe would be completely different, radically different, incompatible with life, and possibly with any complex structure at all. The fine structure constant governs the strength of electromagnetic interactions. It is approximately 1/137. If it were slightly different, if it were 1/100 or 1/200 atoms would not form the way they do. Chemistry would be impossible. Life would be impossible. The cosmological constant governs the expansion of the universe. It has a value so small and so precisely calibrated that physicists have no physical explanation for why it has that value rather than any other. If it were slightly larger, the universe would have expanded too fast for galaxies to form. If slightly smaller, it would have collapsed. It happens to be just right. The ratio of the mass of the proton to the mass of the electron. The strength of the gravitational constant relative to the other forces. The value of the Higgs field that gives particles their mass. All of these constants have the values they have. And if almost any of them were even slightly different, the universe would not support life. This is called the fine-tuning problem. Why are the constants so precisely set? Physicists have proposed various answers. The multiverse. The possibility that there are many universes with many different constants, and we simply find ourselves in one of the rare universes with the right values because we could not exist in the others. String theory, which suggests that the constants might be derivable from deeper principles, not free parameters at all. But another answer, the simulation answer, is that the constants were set by the programmers. That the laws of physics are not fundamental features of reality, but design choices. That whoever built the simulation chose the constants because they wanted a universe that would produce life, or complexity, or minds, or some combination of all of these. In this picture, The fine-tuning problem is not a cosmic coincidence. It is a feature of intentional design. The universe looks fine-tuned because it is fine-tuned. The third clue is quantum mechanics. Quantum mechanics is the most precisely confirmed theory in the history of science. Its predictions have been tested to extraordinary precision and found to be correct over and over for nearly a century. And quantum mechanics describes a universe that is, at its foundations, profoundly strange. Before a quantum system is measured, before someone asks where an electron is, or which direction a photon is polarized, or whether a radioactive nucleus has decayed, the system exists in a superposition. It does not have a definite state. It has a wave function that describes all possible states simultaneously, each with a certain probability. When the measurement happens when someone actually looks, the wave function collapses. From all possible states to one actual state, from probability to fact. This is bizarre. It is not how classical physics works. Classical physics describes a world where things have definite states all the time, whether or not anyone is looking. The electron is in a specific place. The nucleus either has or has not decayed. Whether you measure or not does not change the underlying facts. But quantum mechanics describes a world where the facts only become definite when they are measured, where the act of observation plays a fundamental role in collapsing possibility into actuality. Why would reality work this way? A simulation does not need to calculate what is happening in regions of space that no one is observing. It only needs to render what is actually being looked at. This is how efficient rendering in computer graphics works. You do not calculate the full resolution of every pixel in a scene. You calculate what the observer can see and let the rest remain undefined until it becomes relevant. A universe running on a simulation would be expected to leave things undefined in superposition until a measurement is made. Because calculating definite states for everything all the time, whether observed or not, would be computationally wasteful. You only need to resolve the wave function when something interacts with the system and forces a definite outcome. Quantum mechanics looks, from this angle, like the lazy evaluation of a simulation. The universe only bothers to determine outcomes when someone looks. The physicist James Gates Jr., working on a branch of theoretical physics called supersymmetric string theory, found something that he described as genuinely disturbing. Buried in the mathematical structure of the equations describing the fundamental physics of the universe, he found error-correcting codes. The same type of codes used in computer software to prevent and correct errors in data transmission. Not a vague resemblance, specific, identifiable, formal error-correcting codes. The same mathematical structure that Claude Shannon developed in the 1940s for telecommunications, and that now underlies all digital communication, in the equations of fundamental physics. Gates was clear that he did not know what to make of this. He did not claim it proved we were in a simulation. He said it was simply strange. Deeply strange. The kind of thing that made you stop and wonder whether you were looking at a coincidence or a clue. Why would the fundamental equations of physics contain error-correcting codes? If you were building a simulation of a universe, if you were a programmer making sure your simulated reality stayed consistent and did not degenerate into computational noise, you would build in error-correcting mechanisms. You would not want your simulated physics to drift, to produce inconsistencies, to generate the computational equivalent of static. You would build in codes that detect and correct errors before they propagate into noticeable inconsistencies in the simulated world. And those codes would be woven into the deepest level of the simulation's architecture, into the fundamental equations of the simulated physics, where James Gates found them. None of this proves simulation theory. Each of these features of reality has alternative explanations. The Planck scale might reflect genuine physical structure, not a resolution limit. The speed of light might emerge from the geometry of space-time for reasons that have nothing to do with computation. Quantum superposition might be a real feature of a genuinely probabilistic universe. The error-correcting codes might be a mathematical coincidence or a misidentification. Science requires extraordinary evidence for extraordinary claims, and simulation theory is an extraordinary claim. But the accumulation of hints the way the universe, looked at from a certain angle, rhymes with what you would expect if it were computational, is at least thought-provoking. And thought-provoking tonight is exactly what we are aiming for. Not disturbing, not alarming, just thought-provoking. The kind of thoughts that float in a mind that is gradually becoming still, that are interesting enough to hold the attention, but not demanding enough to prevent rest. Let the breathing slow a little now. We have been moving through some dense and fascinating territory. Quantum mechanics and Planck scales and error-correcting codes. Let it all float. The ideas do not need to be held tightly. They can drift like objects in low gravity, slowly, without urgency. The first and most important thing to say is this. If you are in a simulation, your experience is real. This is not a trivial point. It is the most important point. The pain you have felt is real. The love you have experienced is real. The moments of beauty and grief and laughter and boredom and peace, all of it real. Not less real for being simulated. As real as the experience of any mind that has ever existed. A dream is a simulation. Your brain runs at night. The experiences in a dream while you are having them are real experiences. The fear is genuinely felt. The joy is genuinely felt. The dream version of a person you love feels genuinely familiar. The fact that the dream is generated by your brain rather than by external physical reality does not make the experience less than experience. It is still experience. Now scale that up. Let us grant the premise for a moment, not as a belief, not as a certainty, just as a thought experiment. Just for a few minutes, let us assume Bostrom is right. Let us assume we are in a simulation, and let us ask, what does that actually mean? What changes? What stays the same? What new questions arise, and what old questions take on a different shape? If the universe is a simulation, then everything in it, every mind, every moment, every relationship, every thought, is as real as the experience of the minds having it. The simulation is real. The experiences within it are real. What is not real, or rather, what is not what it appears to be, is the substrate, the stuff underneath, the material out of which the experience appears to be made, the atoms and electrons, and quantum fields that seem to constitute physical reality might be at the bottom mathematical, computational, information rather than matter. But the experience that arises from that computational process that is as real as anything has ever been, you are real, whatever you are made of. The second thing to consider is what kind of simulation this might be. Not all simulations are the same. Not all simulators have the same purposes or the same attitudes toward their simulations. Think about the range of simulations we already build. Some simulations are pure science. Climate models that simulate the behavior of the atmosphere. Particle physics simulations that explore what happens when subatomic particles collide. Cosmological simulations that model the large-scale structure of the universe over billions of years. In these simulations, the goal is understanding. The programmer is interested in what happens. The simulation is a tool for exploring the behavior of a complex system. Some simulations are art, video games, virtual worlds, interactive narratives. The programmer builds a world for aesthetic or experiential purposes to create something beautiful or challenging or moving. Some simulations are records, historical reconstructions, archaeological recreations, simulations built to preserve or explore the past. And perhaps some simulations, if we imagine a civilization far in advance of ours, are something we have no current category for, something that combines all of these purposes and transcends all of them in ways we cannot anticipate. What kind of simulation would produce a universe like this one? A universe with 13.8 billion years of history, with 2 trillion galaxies, with the extraordinary conditions for life that this small corner of the universe happens to have, with conscious beings capable of asking whether they are simulated. What kind of simulator would build this? The second thing to consider is what kind of simulation this might be. Not all simulations are the same. Not all simulators have the same purposes or the same attitudes toward their simulations. Think about the range of simulations we already build. Some simulations are pure science. Climate models that simulate the behavior of the atmosphere, particle physics simulations that explore what happens when subatomic particles collide, cosmological simulations that model the large-scale structure of the universe over billions of years. In these simulations, the goal is understanding. The programmer is interested in what happens. The simulation is a tool for exploring the behavior of a complex system. Some simulations are art, video games, virtual worlds, interactive narratives. The programmer builds a world for aesthetic or experiential purposes to create something beautiful or challenging or moving. Some simulations are records, historical reconstructions, archaeological recreations, simulations built to preserve or explore the past. And perhaps some simulations, if we imagine a civilization far in advance of ours, are something we have no current category for, something that combines all of these purposes and transcends all of them in ways we cannot anticipate. What kind of simulation would produce a universe like this one? Here is a striking observation about our universe that bears on this question. Our universe is, by almost any measure, extraordinarily hospitable to interesting things happening. Not just hospitable to life, which is itself remarkable, but hospitable to complexity, to structure, to the emergence of systems that grow more organized and more intricate over time. The laws of physics allow for the existence of atoms, of molecules, of stars, of galaxies, of planets. They allow for chemistry, for biology, for the emergence of nervous systems capable of experience, for the emergence of minds capable of art and science and philosophy. None of this was guaranteed. A universe with slightly different constants would be a featureless gas, or a universe that collapsed before anything formed, or a universe of pure radiation with no structure. We happen to be in a universe where extraordinary complexity is possible. If you were designing a simulation, if you had the choice of parameters to set, and your goal was to create a universe worth watching, a universe that would generate interesting things, a universe that would eventually produce minds, you would set the parameters exactly as they are. Our universe looks, from a certain angle, like it was optimized for interestingness, optimized for minds, optimized for exactly the kind of beings who would one day wonder whether they were in a simulation. Whether that is because we are in a simulation designed with this purpose, or because the anthropic principle explains it all. We could only find ourselves in a universe capable of producing us is one of the genuinely open questions. But it is a striking observation either way. What kind of simulation would produce a universe like this one? One designed by someone who wanted minds in it. And not just minds, minds that ask. Some thinkers have suggested that the simulation hypothesis converges in unexpected ways with religious ideas about the relationship between the creator and the created. If we are in a simulation, then there is, in some sense, a creator, an entity or entities who built the system in which we exist, who designed the laws of physics that govern our experience, who decided the initial conditions from which our universe evolved. That entity, or those entities, would have properties that are, in certain respects, godlike. They would exist outside of our universe. They would be causally responsible for our existence. They would have access to the fundamental structure of our reality in ways we do not. They might be able to modify the simulation, to introduce anomalies, to run experiments, to observe everything that happens within it. This does not make simulation theory a religion. The simulating civilization would itself have been evolved or built or emerged through some process. They would not be supernatural, they would just be more advanced than us. But the functional relationship between simulator and simulated is not entirely unlike the functional relationship that many religious traditions describe between creator and creation. The philosopher David Chalmers has noted this connection carefully. He argues that if simulation theory is true, it does not undermine theism. It provides a novel way of understanding the relationship between a creator and a created world that is compatible with, though not identical to, many traditional theological ideas. This is not an argument for any specific religion. It is an observation about the structural similarity between two very different sets of ideas. And it is worth sitting with. Not to draw conclusions, but because the convergence of ancient theology and modern philosophy of computer science on similar structural questions is itself interesting. The old questions about why there is something rather than nothing, about whether the universe was made, about whether there is a mind behind the order we observe. These questions do not go away in the context of simulation theory. They become, in some ways, more pressing. Here is something that the simulation hypothesis raises that is genuinely strange. If we are in a simulation, we might be able to detect it. Not easily. Probably not with current technology. But in principle, if the simulation runs on finite computational resources, if it is not a perfect simulation, but one that cuts corners in the way real-world simulations always do, then those corners might leave traces. The cosmic ray spectrum is something we are still measuring and understanding. The energies involved push the limits of what our detectors can measure. The test is not definitive. But the fact that there is a test at all, the fact that a physical, measurable consequence of living in a simulation might exist, is remarkable. It means simulation theory is not just philosophy, not just logic. It is, in principle, science. It makes predictions. And those predictions could, in principle, be confirmed or disconfirmed. That is not true of most ideas this philosophically radical. There is a related idea that some physicists have taken seriously. If we are in a simulation, we might be able to find the code, not the literal programming language, but evidence of the mathematical structure, the computational architecture underlying physical reality. Some physicists have proposed that this is what they are already doing when they discover mathematical structures governing the behavior of subatomic particles. Structures like the standard model of particle physics or the equations of quantum field theory, they are, in effect, reading the code. The universe is described by mathematics with extraordinary precision and elegance. The mathematical structure is so deep and so consistent that many physicists have come to believe that the universe is not described by mathematics, it is mathematics. That physical reality at its deepest level is mathematical structure. This view, called mathematical universe hypothesis by its main proponent, the physicist Max Tegmark, implies something very close to simulation theory. If the universe is a mathematical structure, then it is, in some sense, a computation. The laws of physics are the algorithm. The universe is the output, whether that computation is being run on a computer outside the universe or whether it simply exists as a mathematical truth that does not require an external computer to be real. That is one of the deep questions that mathematical universe hypothesis raises. But in either version, the universe is, at its deepest level, information, pattern, structure, and the question of who, if anyone, is running the computation is a question that may eventually be answerable. Let your breathing slow a little more now. The ideas have been moving through dense territory. Physics and computation and theology and the nature of mathematical reality. Let it all settle. Let the mind become a little softer. The questions are large. The night is quiet. You do not need to answer anything. Just let it be. Simulation theory is compelling, but it is not without serious critics, and their objections are worth hearing because they sharpen the picture. The first objection is philosophical. The philosopher David Deutsch, one of the originators of quantum computing theory, argues that Bostrom's argument contains a hidden assumption that does not hold up under scrutiny. The assumption is that consciousness can be simulated on a digital computer, that a computational process running the right algorithm would produce genuine experience, that the pattern matters, not the substrate. Deutsch disagrees. He follows a line of argument similar to Roger Penrose, who argued that human consciousness depends on quantum processes in the brain, specifically on what Penrose called orchestrated objective reduction in microtubules that cannot be replicated on a classical digital computer. If Penrose and Deutsch are right, then a digital simulation could not produce genuine consciousness. It could produce behavior that looks like consciousness from the outside. But the inner experience, the genuine felt quality, would not be there. And if conscious experience cannot be simulated on a digital computer, then the argument that most minds are simulated collapses, because a simulation of a brain would not be a simulation of a conscious mind. It would be a simulation of a philosophical zombie. This objection is serious. It goes right to the heart of the hard problem of consciousness, and it is unresolved. The second objection is physical. Simulating a universe in adequate detail requires an extraordinary amount of computation. The physicist Seth Lloyd has estimated the total computational capacity of the observable universe if every particle and every interaction were used for computation at roughly 10 to the power of 90 operations. Now consider what it would take to simulate that universe. To simulate every particle in the universe, you need at least as many computational operations as there are particles and interactions, which means you need a computer at least as large as the universe itself. And a computer that large would need to be part of some larger universe, a base reality in which the computer exists. This is not an impossible objection to the simulation hypothesis. You do not need to simulate every particle to simulate a convincing conscious experience. The simulation could be approximate low resolution in regions not being directly observed, high resolution only where it matters. This is exactly how efficient rendering in computer graphics works. You do not compute the full detail of a scene. You compute what the observer can see, at the resolution the observer can detect, and let everything else remain approximate. The third objection is what philosophers call the regress problem. If we are in a simulation, what is the base reality? Whatever it is, it must be a physical universe, or at least a computational substrate, that runs the simulation. A universe with its own laws of physics, its own material reality, its own structures capable of running computations. Where did that universe come from? If it was itself simulated, then we need a third level, the simulator of the simulator. And that third level needs a fourth, and so on. Either the regress goes infinitely backward, an infinite stack of simulations with no base, or it terminates somewhere. At some level, there must be a physical reality that is not simulated, a base reality that just exists without being a computation running inside something else. What is that base reality like? If our universe is a simulation, it might be running this kind of approximation, which would mean that the deep structure of our universe, the behavior of particles at scales below what any experiment can probe, might be rough, uncomputed, rendered in lower resolution than everyday experience. And this connects back to the quantum mechanics observation. The universe only resolves definite states when measured, which is exactly what an efficient simulation would do. We have no idea. It might operate on completely different principles from our universe. It might not have atoms or quantum fields or any of the structures we associate with physical reality. It might be unimaginably alien. And if the base reality is so different from our universe that we have no framework for understanding it, then the question of why our particular simulation was created, by whom, and for what purpose, becomes truly unanswerable. This does not refute the simulation hypothesis, but it's honest about the depth of the not knowing that it opens. The fourth objection is perhaps the most practically grounding. It is simply this: we have no evidence. Despite decades of searching for anomalies in the structure of physics that might indicate computational limits, despite serious efforts to look for the signatures of a simulation, we have found nothing. The cosmic ray energy cutoff that Bean and colleagues predicted in 2012 has not been definitively detected. The error-correcting codes that James Gates found in supersymmetric string theory are contested. Other physicists argue they reflect the mathematical structure of the theory rather than any feature of an underlying computation. The digital structure at the Planck scale is consistent with simulation, but also consistent with many other theories of quantum gravity. Absence of evidence is not evidence of absence, but it is worth noting. The simulation hypothesis makes predictions. Those predictions have not been confirmed. Science requires confirmation, not just consistency. What should we make of all this? The honest answer is, we do not know. The simulation hypothesis is a serious argument that has not been refuted, but it has also not been confirmed. It sits in the genuinely uncertain middle ground between wild speculation and established fact, the same ground occupied by many of the most interesting ideas in the history of human thought. It is possible. It is perhaps more than possible. It is logically compelling in a way that makes dismissal feel intellectually unsatisfying, but it is not established, not certain, not something you have to believe. What it is a question worth sitting with, the same way all the best questions are worth sitting with. Breathe slowly. The objections have been heard. The argument has been made. The mystery stands as it has always stood. Let the mind relax around it now. Let the question float rather than press. There is a question at the center of simulation theory that is harder than all the others, not harder to answer, impossible to answer, at least for now, but harder in the sense of being the place where the deepest uncertainty lives. The question is this: if you are in a simulation, are you conscious? Not whether you feel conscious. You clearly do. The experience of awareness, of being here, of something happening that is undeniable from the inside. The question is what that experience is made of. Is there something it is genuinely like to be you? Is there real subjective experience, the inner feel of things in the computation that produces your apparent thoughts and feelings? Or are you something like a very sophisticated philosophical zombie, a computation that behaves as if it is conscious, produces all the outputs associated with consciousness, but has no inner experience, no light on inside? This is the hard problem of consciousness, as we have encountered it before, and it is, in the context of simulation theory, particularly pointed. Because simulation theory does not automatically answer it. One possibility, perhaps the most comfortable, is that consciousness does not depend on the substrate. If what matters for consciousness is the pattern of information processing the functional organization rather than the specific physical stuff doing the processing, then a simulated mind would be as genuinely conscious as a biological one. This view is called functionalism. It holds that mental states are defined by their functional roles, by their relationships to inputs, outputs, and other mental states, rather than by the specific physical implementation. In this view, if a computer runs a program that processes information in exactly the way a human brain processes information, with the same functional organization, the same patterns of activation and suppression, the same causal relationships, then the program is conscious. It has genuine experiences. There is something it is like to be it. And so if you are a simulated mind, would be genuinely conscious. The simulation would be generating real experience, not just the appearance of experience. Another possibility is that consciousness requires something specific about biological substrate, something about the way carbon-based neurons interact, about the specific chemistry, about physical processes at scales below what any simulation would replicate, something that gives rise to genuine experience and that cannot be captured by a purely mathematical or computational description. If this is right, then a simulation, however detailed, would not produce genuine experience. It would produce behavior that looks like experience from the outside, but there would be nothing it is like to be the simulation. No inner light, no actual feeling. This view has been argued by philosophers like John Searle, who famously constructed the Chinese room thought experiment to argue that computation alone cannot produce genuine understanding or consciousness. Searle imagined a person sitting in a room, receiving Chinese characters through a slot, looking them up in a rulebook, and passing back the appropriate Chinese characters in response. The person does not understand Chinese. They are following rules. But from outside the room, it looks like someone inside understands Chinese. Searle argued that a computer running a program is like the person in the room following rules, producing outputs that look like understanding, but with nothing genuinely understood on the inside. Whether Searle is right is one of the most contested questions in philosophy of mind. But if he is, it raises something unsettling about simulation theory. If the simulation does not produce genuine consciousness, if the computational process is just a philosophical zombie, producing behavior without experience, then what are you? You certainly seem to have experiences. You feel pain and joy, and curiosity and tiredness. You have the unmistakable sense of there being something it is like to be you. But in a simulation without genuine consciousness, that sense would itself be part of the computation. The simulation would include the computational equivalent of the sense of being conscious, the reports of experience, the behavior associated with experience. Without the experience itself, this is a genuinely disorienting possibility, and there is no way from inside the simulation to determine whether it is true. There is a third possibility that some philosophers and physicists have taken seriously. Consciousness might be fundamental, not something that emerges from physical processes, biological or computational, but something that is a basic feature of reality itself. This view is called panpsychism. The philosopher David Chalmers, who is also one of the most careful thinkers on simulation theory, takes it seriously. The physicist Roger Penrose has proposed related ideas. The philosopher Thomas Nagel argued for something in this vicinity. The idea is that experience the inner feel of things, the basic quality of there being something it is like to be something is not produced by physical processes, but is present wherever there is organized information processing. Not necessarily rich, human-like experience, but some basic form of what might be called proto-consciousness, a primitive version of the inner light that, in beings like us, takes the rich and complex form of human awareness. If panpsychism is right, then the question of whether a simulation can be conscious does not depend on whether the simulation is sufficiently sophisticated to produce emergent consciousness. Consciousness is already there, woven into the computational process itself. The simulation is conscious not because it reaches some threshold of complexity, but because consciousness is present wherever information is being processed, which means the computer running the simulation might also be conscious, and the physical processes in the base reality, whatever that is, might also be conscious, and every layer of reality, all the way down, might be shot through with something like experience. This is a very old idea in a very modern context. Illusionism says that the hard problem of consciousness seems hard because we are systematically mistaken about the nature of our own experience. We think experience has a kind of inner richness, a specific, ineffable quality that sets it apart from mere information processing. We think there is something it is like to see red, something over and above the processing of light at certain wavelengths that is not captured by any functional description. Illusionism says this intuition is wrong, that what seems like the irreducible inner quality of experience is itself a representation, a way the brain models its own states. There is no further fact about what redness feels like beyond the way the brain processes and represents information about color. In this view, the hard problem of consciousness is not hard. It is the result of a systematic illusion. The brain's tendency to model its own states in a way that makes them seem to have a depth and richness that they do not actually have. If illusionism is right, then a simulation could be conscious in exactly the same sense that biological beings are conscious. Because what makes biological beings conscious in the illusionist picture is not some magical inner quality that transcends information processing. It is a specific kind of information processing that includes the representation of the processing as having inequalities. A simulation that includes the right kind of self-modeling would be conscious in exactly that sense, not more, not less, which is all the consciousness any of us have, according to this view. What does any of this mean for tonight? It means that the question of what you are, what this awareness is, what this experience of being here in the dark consists of, is genuinely, irreducibly open. Not in a distressing way, in an interesting way. The interesting way that large open questions have when you encounter them late at night with nowhere to be and nothing to figure out. You are here. Something is aware. The experience is undeniable. What it is made of, whether it is neurons firing in a biological brain in a physical universe, or information processing in a simulation, or the fundamental consciousness of a panpsychist reality, none of those answers changes the experience itself. The experience simply is, and it is enough. Breathe slowly. Let the body settle. Let the thinking become lighter. We are past the midpoint of the night. The ideas have done much of their work. Now they can drift. If we are in a simulation, who built it? This is a question that most treatments of simulation theory treat quickly. Advanced civilization, future technology, that is roughly enough, and move on. But it is worth slowing down here, because the nature of the simulators, who they are, what they want, what their relationship to us might be, is not actually a question we can fully answer, but one that is worth thinking about slowly, in the way that interesting things deserve. The most likely possibility, given Bostrom's argument, is that the simulators are our descendants. Not our direct descendants, not our grandchildren or great-grandchildren, but descendants in the longer sense. The civilization that grows from what we are now over millions of years, through changes we cannot anticipate. If the simulation is an ancestor simulation, a detailed recreation of an earlier stage of the simulator's history, then we are not a fiction. We are a reconstruction. We are, in a sense, being remembered. The civilization in the future has decided to understand where they came from. They have decided to recreate, in detail, the stage of development through which their ancestors passed, the stage we are at right now. And if we are that recreation, that memory, then there is something in our existence that is held, consciously, by the minds that made us. They know we are here. They know what we are going through. They are watching, or at least have watched, the story of our civilization unfold. There is something in this that is, unexpectedly, not lonely. If we are in an ancestor simulation, we are not alone in the universe. We are not an accidental arrangement of atoms in an indifferent cosmos. We are a deliberate creation of minds that, in some sense, are us our successors, our descendants. The civilization we might become. We are a story they are telling themselves about their own beginning. But the simulators might not be our descendants. They might be something more exotic. They might be a civilization that evolved independently on a different world, in a different galaxy, billions of years before we came into being. A civilization so different from us that we would not recognize them as minds at all. They might be running simulations for purposes we cannot imagine, not out of historical curiosity, not out of any motive we would recognize. Maybe the simulation is an experiment, a test of how conscious beings develop under certain conditions. Maybe the simulation is an art form, a universe-scale creative project. And what happens within it, the full sweep of cosmic and biological and cultural history, is the work. Maybe the simulation is something beyond our categories entirely, a kind of reality we have no concepts for, something for which science and art and experiment and recreation are all inadequate descriptions. We simply do not know. And this not knowing is not a failure. It is simply the honest acknowledgement of the limits of what can be known from inside. There is a question that follows naturally from all of this. Could we communicate with the simulators? In principle, there are ways to imagine it. Messages embedded in the structure of the simulation that its inhabitants could eventually discover. Anomalies introduced into the physics that signal the presence of an external intelligence, something like the monolith in Arthur Clarke's 2001, an object of extraordinary regularity that could not have arisen naturally, placed where it would eventually be found. Or perhaps the communication runs in a different direction. Perhaps the act of asking the question of developing the philosophy and physics and mathematics to even frame the simulation hypothesis is itself a kind of message sent back to the simulators. You built conscious beings capable of wondering whether they are simulated, and they are wondering. And that wondering is itself evidence that the simulation has reached the intended stage of development, that the beings within it have reached the level of philosophical maturity required to ask the deepest questions about the nature of their reality. Perhaps the simulators are waiting for exactly this. Perhaps this conversation, this slow late-night exploration of what reality is, and whether it is what it seems is, in some sense, a signal. Not a message sent anywhere, but a signal in the sense of a marker. Evidence that the program is running as intended, that the consciousness generated by the simulation has become recursive, has turned back on itself and asked in the dark whether the room it lives in is real. There is a thought that follows from this that is worth staying with for a moment. If we are in a simulation designed to produce minds, then the act of being a curious, questioning, wondering mind is not a small thing. It might be the whole point. Not the accumulation of power or resources, not the conquest of territory or the achievement of security, but the specific act of asking, of wondering, of following an idea as far as it goes and then following it further. The universe, simulated or physical, seems to have arranged itself so that minds arise, so that the questions get asked, so that awareness turns back on itself and examines its own foundations. If that is a feature of the design, then tonight, this specific act of lying in the dark and thinking slowly about the deepest questions is exactly what this universe was built for. That is not nothing. There is a related question that is even harder and even more interesting. Could the simulators intervene? Could they, if they chose, modify the simulation, alter the physics, change the initial conditions, introduce new elements that would not arise naturally? In principle, yes. Obviously, the simulators have access to the fundamental architecture of the simulation in a way that nothing inside it does. They can do anything that is computationally possible. Whether they would choose to intervene, whether they do intervene, is unknowable from inside. But this possibility maps onto something that humans have always intuited. The sense that things are not entirely determined by the natural order, that something outside ordinary causality sometimes seems to be operating, that coincidences are occasionally too perfect to be coincidences, that moments of grace or intervention, or what feels like help from outside, are sometimes encountered. These experiences are real in the sense that people genuinely have them, whatever their ultimate explanation. And simulation theory offers a novel account of what they might be. Not supernatural in the sense of being outside nature, but interventions from outside the simulation, adjustments made by the programmers, small tweaks to the parameters that ripple through into experience reality as moments that seem, from within, inexplicable. This is not an argument for any religious tradition. It is an observation that the simulation framework makes room for something that many human traditions have always made room for, the possibility that the world is not entirely self-contained, that something outside it is occasionally at work within it. There is one more observation about the simulators that is worth making. If the simulators are our descendants, if this is an ancestor simulation, then they know how our story ends. They know what happens to human civilization. They know whether we survive the challenges ahead. They know whether we reach the point of technological maturity that they themselves have reached, whether we figure things out, whether we make it. This is strange to sit with. Somewhere in the future, there are minds who know our fate, who are watching or have watched our history unfold. The full sweep of it, the early chapters we are living through right now, the chapters that come after, all the way to the end. and they chose to simulate us, to recreate us, to give us, in some sense, a second life in the memory of what we became. Whether that is comforting depends on who you are and what you believe about the nature of existence. But it is a possibility that the simulation hypothesis opens, and it is a strangely peaceful one in its own way. We are being remembered by our descendants, not forgotten, not erased, not simply gone, but held in the memory of the civilization we were the ancestors of, running in some sense still. Let the mind rest now with these images, the simulators, somewhere outside our universe, watching or not watching, having run the simulation and left it to unfold, having set the initial conditions and walked away, or having never existed at all, and the universe being simply what it is, physical, real, not a simulation. All three possibilities are in the air tonight. All three are interesting. None of them changes what is real about this moment. The awareness here, the breath moving, the darkness of the room, these are real, regardless of which story is true. Let us ask the question that philosophy always eventually has to face. So what? If simulation theory is correct, if we are in fact living inside a vast computation run by a more advanced civilization, what does that change about how we live? What is different? What is the same? The honest answer, in most ways, is nothing is different. The world you experience is the world you have to live in. Whether it is built from quantum fields or from bits, the coffee is hot or cold. The people you love are here or not. The work you care about matters or doesn't. The choices you face are real choices with real consequences within the simulation. Even if you are a simulated being, you are a simulated being with genuine experiences, genuine relationships, genuine values, genuine mortality. The simulation does not suspend any of that. It does not make suffering less painful, kindness less meaningful, beauty less beautiful. It does not make the relationships between people less real, the effort to understand the world less valuable, the project of living well less important. Wittgenstein's point about solipsism applies here too, with the same force. If simulation theory is true, and you live accordingly, treating people with care, making choices with integrity, working toward things that matter, being present to what is good, you will live exactly the same way as you would if it is false. The theory has no behavioral consequences that distinguish it from its negation, which might be the best possible thing to say about a theory this radical. It is compatible with life. It does not undermine anything that actually matters, but it does change some things. It changes the quality of wonder. If the universe is a simulation, if someone or something built this, then the fact that it contains mathematics of such extraordinary elegance, physics of such extraordinary consistency, chemistry that gives rise to life, life that gives rise to consciousness, consciousness that gives rise to art and music and love and philosophy, all of this takes on a different character. It is not just what happened, it is what was made. The beauty of the world, the specific beauty of this world with its particular laws and constants and structures, is not accidental. It is chosen, or at least allowed by an intelligence that could have chosen otherwise. Whether you experience that as comforting or disturbing probably depends on who you are. But it is, at minimum, interesting. The universe, looked at through the simulation hypothesis, is not a brute fact. It is a creation. And like all creations, it reflects something about its creator, something about what they value, what they were trying to achieve, what kind of world they thought was worth making. It also changes something about loneliness. One of the deep fears that underlies human experience, not always conscious, not always named, but present, is the fear that the universe is indifferent, that there is no one home at the level of ultimate reality, that the cosmos is vast and ancient and impersonal, and that our existence, however vivid it feels from inside, is of no consequence to anything larger than ourselves. The simulation hypothesis offers a direct counter to this. Here is something else that simulation theory changes. It changes the scale of the possible. In a physical universe, the laws of nature are what they are. Physics is fixed. The boundary conditions are set. The space of possible experience is the space that these specific laws and constants allow. In a simulated universe, the laws of physics are chosen. They are parameters set by the programmers, and parameters can be changed. Not by us, not from inside. We cannot reach the controls. We cannot change the speed of light, or the strength of gravity, or the constants that determine the behavior of matter. But the fact that they are parameters, the fact that the universe could, in principle, run differently, means that the space of possible experience is not limited to what these specific laws allow. The simulators might have run other universes with other parameters, universes where light travels at different speeds, where gravity is stronger or weaker, where matter behaves in entirely different ways and gives rise to entirely different kinds of complexity and life and mind. We cannot visit those universes. We cannot imagine them. Probably because our imagination is shaped by the specific parameters of this one, but they might exist. Other universes in other simulations, each one a different experiment, a different creative project, a different exploration of what is possible. The space of possible experience might be far larger than anything this universe can provide. This is not a reason to be dissatisfied with this universe. This is a reason to find it remarkable that this particular universe, with its particular parameters, produced this particular awareness here, tonight, thinking about all of this. Out of all the possible simulations that could have been run, you find yourself in this one, which is, whichever way you look at it, extraordinary. But simulation theory opens a different dimension of meaning. If we are an ancestor, simulation, if we are a recreation of the early history of a future civilization, then our lives have meaning not just for us, but for them. We are their origin story, the things we figure out, the mistakes we make, the culture we build, the science we develop, the art we create. All of it is part of what they are learning about their own past, their own roots, their own beginnings. We matter to them, not just as data points, but as ancestors, as the beings who lived at the beginning of the long story that produced them. In most human cultures, the ancestors are honored, they are remembered. Their lives and choices and struggles are understood as foundational. If we are simulated, we are the ancestors of the civilization that simulated us. We are the foundation of their story. That is not a small thing. Here is one more thing that simulation theory changes. It changes the relationship between the finite and the infinite. In a physical universe, your life is bounded. You are born, you live, you die. The matter that constitutes you disperses, recombines, becomes other things. your individual existence ends. This is the basic fact of human mortality, and how to relate to it has been one of the central challenges of human culture for as long as humans have existed. In a simulated universe, there is a different possibility. The simulation is code. Code can be saved. The state of the simulation at any moment, every particle, every quantum state, every configuration of matter and energy could, in principle, be recorded, stored, preserved. This does not mean it is. The simulators might have no interest in preserving specific configurations. They might run the simulation and let it run without intervention, not caring about any particular state within it. But it is possible. The possibility exists within the simulation framework that every moment of every life, including yours, including tonight, is being preserved somewhere. Not in memory, not in the imperfect records of history, in a permanent record at the level of the simulation's architecture. Not an afterlife in any traditional sense, but something that rhymes with it. A permanence that does not depend on biology or memory, or the fragile transmission of cultural records. A permanence built into the structure of what this is. Whether it is real, whether any such preservation is happening is not knowable from inside, but the possibility is there, and possibilities sometimes are enough. Let your breathing slow now to the pace of deep rest. Let the body go heavy. Let the mind release the need to follow the ideas closely. Just let them be there, in the room, in the night, in whatever this is. The night is very deep now. The questions have been asked. They will still be there in the morning. They have been there, in various forms, for thousands of years. They can wait. Right now, in this moment, one thing is certain. Something is here. Something is aware. Something is noticing this darkness, this quiet, this voice. Whatever it is made of neurons or code or something we have no language for, it is here. It is real. It is enough. It is. Think about what it means that this awareness exists at all. Whatever the universe is physical, simulated, or something beyond both categories it has produced, somewhere within itself. Something that asks questions. Something that lies awake and wonders. Something that is not content simply to exist, but needs to understand what existence is. That need, that restlessness of mind, that inability to simply accept the world as given might be the most remarkable thing the universe has ever produced. It might also be the thing the simulators most wanted to create. Not power, not beauty, not order. The asking, the wondering. A mind that turns back on itself and asks, what is this? You are doing that tonight. You have been doing it for as long as you have been able to form thoughts. And whether that is a feature of biological evolution, or a designed property of a simulation, or simply what consciousness does when it is given enough time and enough quiet, it is yours. It belongs to you. It is perhaps the most distinctly yours thing about you. Whether the universe is physical or simulated, you are connected to those other patterns. Connected by experience, by memory, by care, by the fact that their configurations have changed yours, and yours have changed theirs. And those changes are permanent in whatever record of this reality exists. The simulation, if there is one, runs all of it at once, not separately, not in isolation, together. All the patterns interacting, all the connections operating, all the relationships running simultaneously in whatever computation underlies this night. You are not alone in the simulation. You are surrounded by other patterns that matter to you and to whom you matter. Whatever else is uncertain, that is real. Somewhere, in whatever is outside this universe, if there is an outside something might be watching this moment, a mind that built all of this, watching one small program drift towards sleep, or no one watching, just the universe, turning. Either way, the moment is real. The computation continues. All the particles, or the information representing particles, following their trajectories through the simulated space. All the stars burning, all the galaxies slowly rotating, all the billions of lives being lived, all the minds thinking their thoughts and feeling their feelings and drifting towards sleep in the dark. The simulation, if it is a simulation, is extraordinarily large. But here, at these coordinates, in this particular instance of consciousness, things are very small, very quiet, very simple. Just this breath, just this awareness, just this moment, settling toward rest. The questions have done their work. They have opened something. They have made the world a little larger and a little stranger and a little more interesting than it was before. And now they can rest. You do not need to hold the simulation hypothesis. You do not need to decide whether it is true. You do not need to do anything with any of the ideas that have been moving through the mind tonight. They will settle on their own into the deeper parts of thought, where they will continue, slowly, to do whatever ideas do when they are no longer being actively thought. The breath moves in, very slow. The breath moves out, very slow. The thinking is almost gone. Just the breath, just the dark, just the awareness, fading towards something quieter than awareness. The computation continues. You do not need to. Good night. Whether the universe is physical or simulated, the atoms that make you, or the information that represents you, have been assembled into something that can wonder about its own nature. That is extraordinary. In 13.8 billion years of history, in the vast majority of places and times, nothing wondered. Stars burned, galaxies collided, planets formed and cooled. For billions of years, the universe existed without any part of it asking what it was. Then slowly, improbably, impossibly, the matter arranged itself into something that could ask. You are part of that asking. One small, temporary, irreplaceable part of the universe's capacity to wonder about itself. Simulated or physical. Real. Breathe in. Breathe out. Somewhere, in whatever is outside this universe, whether that is physical space and time, or a computer running the simulation, or simply nothing at all, the universe continues. It does not need your attention. It does not need you to figure it out tonight. It has been running for 13.8 billion years without your help. It will continue. And here at these coordinates, in this body, in this moment, something is resting. The thinking is slowing. The questions are becoming quieter. Not answered, just quieter. The way questions become quieter late at night when the mind is tired and the body is heavy and the darkness is warm. If the simulators are watching, if there is someone somewhere running this computation and observing its output, they are watching a mind go quiet, a pattern of information settling toward a different state, the state of rest, of sleep, the state in which the computation runs differently, more slowly, more inwardly, processing what the day accumulated, consolidating, releasing. The simulators, if they exist, have built into the simulation the necessity of sleep. Every conscious being in the simulation, every night, returns to this state, this letting go, this surrender of the waking self to something deeper. Maybe they did that on purpose. Maybe they knew that consciousness, to remain whole, needs this, needs the dark, needs the quiet, needs the place where thinking dissolves and something else takes over, something older, slower, more basic. The computation beneath the computation, the process beneath the thought. You are somewhere on the edge of that now. The thoughts are thin, like smoke, like the last light before dark. The universe is running, the simulation is running, or the physical world is turning. Either way, you do not need to hold it. It holds itself. All the people you love are at their coordinates. All the places you know are at their coordinates. All the moments you have lived are at their coordinates. All of it in the computation, all of it running, all of it real. And here, at these coordinates, this breath, this quiet, this letting go, is also in the computation, also real, also running. Somewhere outside the universe, if there is an outside, something might be watching this moment. A mind that built all of this, watching one small program drift towards sleep, or no one watching, just the universe, turning. Either way, the moment is real. The breath moves in, slow. The breath moves out, slow. The thinking is almost gone. Just the breath, just the dark, just the awareness, fading towards something quieter than awareness. The computation continues. You do not need to. Good night.